that we need to shift from seeing the world as composed mainly of machines to seeing it as composed mainly of complex systems. The roots of complexity science really originate in physics and mathematics, and then computer science and information theory, and more recently, interestingly enough, ecology. Ecologists deal with intrinsically complex systems. Clocks can be taken apart, analyzed, and fully understood. They are no more ultimately than the sum of their parts. And that's a really fundamental principle or property. They show, these simple machines, proportionality of cause and effect. Small causes cause small effects, big causes cause big effects. They exhibit normal or equilibrium patterns of behavior. And because of these characteristics, machines can be managed and their behavior can be predicted. Well, it turns out that complex systems throw a wrench into that view of the world. They are more, ultimately, than the sum of their parts. They exhibit emergent properties. You put all the bits and pieces together, and the whole has novel properties. I want to emphasize the importance of connectivity in these systems, and the fact that these things are working interactively. Complex systems show disproportionality of cause and effect. Small causes can sometimes cause big effects. Under some circumstances, especially when you've got a lot of tight coupling in a system, you have a shock and it proliferates like a row of falling dominoes all falling over. It cascades through the entire system. The financial crisis started in a relatively small part of the global economy, but within a relatively short period of time, about a year or so, caused a cascading effect that caused every single economy in the world to go into recession simultaneously. Now that is a brittle system. It's not a resilient system. Complex systems can flip from one pattern of behavior to another, and often it's very difficult to determine which place they're going to be in, or when they might shift from one equilibrium to another. As a result of these three characteristics, complex systems cannot be easily managed because their behavior is often highly unpredictable. What's causing our economies and societies to become more complex? More nodes, a greater density of connections among nodes. Nodes, as I say, can be technologies, corporations, individuals. And in turn, we've seen faster movement of material, energy, and information along these increasingly dense connections. So you're getting more connections, and you're getting faster movement of stuff along those connections, and that has tightened the coupling in the system. There is an urgent need for new tools. At least some of them are going to emerge from this field.